Want to go and wait for? You good? Okay. So good afternoon. Finally, we went through all the technical problems, and first of all, I would like to thank you for coming to first Mikrotik user meeting in Canada. We're all excited having you guys here, and we've been, as I see the presentations, there's several of them regarding redundancy and failover. Somebody will say that here we in Canada are obsessed with the keeping network up and running. So my presentation is around keeping 100% up, and there was an overlap with some of the other presentations that are done earlier. So I decided to change a bit of order to actually make it a bit more interesting for you guys. So I'm going to stay more on a high level view and some of the scenarios and how that can be handled rather than getting too much into code and kind of technical view. To get it started, first, my name is Jovan Strika. I'm representing Macrotik. Macrotik is a provider of networking equipment and management services. It's all based on the Mikrotik router boards. We've been exhibiting earlier there, and besides the hardware, we also introduced the cloud services. It's a monitoring and management using the Mikrotik scripting capabilities. In regards to today's presentation, I'm going to go through a bit of a redundancy overview. I'm going to talk about 4 areas that I kind of identify as a reason where that can cause a kind of outage. And at the end, I'll talk a little bit about available resources. So when we look at the challenges in the businesses, nowadays everything is IP-based. It's not just the data. We have a voice. We have security, payment processing. So keeping network up and running became a kind of critical task. And it's not just business continuity. There is a need from regulatory requirements to keep the network up and running. And when we look at the deploying redundant network, well, there are quite often limited budgets as well as expertise. Having a network fully redundant requires quite high expertise. And when you look at the internet, it's quite costly to keep 2 connections up. There is inadequate power redundancy as well on site. We have expensive devices very often spared and duplicated on the network to kind of keep just in case. We see quite increasing number of devices, especially with the bring your own device. So we have tablets and phones now as being workstations together with the rest of the equipment. When we look at the solutions from a Macrotik side and holistically, what are the problems? We first of all wanted to introduce something that is really cost effective. We know that when it comes to redundancy and enterprise budgets, there was a lot of answers and a lot of different vendors introducing their solution. But really introducing something that is very cost effective, especially for small and medium-sized business, or even if it's a big corporation, but let's say a retail stores with a lot of small sites that sort of act as a small, medium business, achieving redundancy across all these locations is very often too expensive, even for the large companies. So we look into how we can leverage Mikrotik hardware and scripting capabilities and introduce creative ways of have the redundancy in the network. So we explored 3G and LTE as a failover, so I'm going to talk a little about that. Then how we address the power problem with integrated UPS and the battery. We will talk about failover options, and I'm going to brush on a VRP methods and keeping it redundant. Elaine, in an earlier presentation, went a bit more into details with VRP. I heard there was a lot of questions, so hopefully you guys will be gentle. And when it comes to the seamless failover on the LAN side, it's also critical to look into how we can achieve redundancy in the local network. So if we look at from the high-level view, a network diagram, and I tried to make this slide not very busy. So I kind of put in the first, obviously, internet access, And typically it's provided from your internet service provider, being DSL, cable, or nowadays we see more and more fiber deployed with a lower cost of the fiber. And then another area that we see as a kind of challenge is the power. Very often we see devices just plug directly into the outlets without really power protection. Routers nowadays, with all the integrated devices, you can have 3 different network elements, such as access point, switch, or the router. Or if it's a small site, you can have something that integrates all these 3 components into one device. So I'll talk about how we can address the redundancy on the router level, and at the end, how to keep the local network up and running as well. So to start first with the internet, there is no really magic on an internet side. We need a second link. Having a redundancy requires having a second connection. Now, when we look into deploying a second wire connection, being, let's say, a DSL cable, well, first of all, redundancy should really be around getting alternative link. So having 2 DSLs from 2 different providers is not really the redundancy that you would like, because they are sharing a backbone network. So having a cable and DSL, so completely different type of the networks, is way better redundancy than having it, for example, 2 DSL links. And when you look at routers, there's many of them that already provide WAN 1, WAN 2. With Mikrotik hardware, it's interesting. We can take any Ethernet port and allocate it as a WAN port. So it's not predefined WAN 1, WAN 2 type of the connections. You can means have more than 2 WAN connections per router. And at the same time, they can be used simultaneously. We saw some routers from the other vendors that they have a second link really idle, not really in use unless the first one fails, where with our routers we can actually have both links connected at the same time. And when it comes to the traffic, so what you can do, you can load balance, or you can actually define based on the what are called mangle and marking rules, which clients will talk through one connection. So you can have a voice service running through one type of connection and data service going through the other type of connection. When it comes to the route robin, there is a different method how to set it up. Every new TCP connection to be established to the kind of different WAN. So you have a bit of options according to how your traffic should be designed, which method you will take. But when it comes to the outage, so when one internet provider fails or the connection fails, Mikrotik has the ability to monitor that connection. There is several different ways how you can achieve that. By just implementing a method of monitoring of your WAN side, there is an option to say by ping or by ARP. That interface can be monitored, and when there is a recognition that there is no next hop available, means, okay, your last mile is gone, system can automatically fail over to the second link. If you want to go more advanced monitoring, there is either using the NetWatch or using a custom scripting, and that actually then gives you more than just monitoring last mile. You can actually monitor deeper in the network and see if there is outage, and then fail over to the next link. And in case if it fails, then both type of traffic are then routed through the remaining link. So that's where a queuing option comes in place, which is based on the traffic that you prioritize and you marked. You can now say, okay, I want voice having a higher priority than data. So once you have the kind of one link, then you can really optimize and decide how that will be used. And another great advantage of these routers is that it can also execute additional script. What this means is that if you see an outage on one of the connections, this can actually send you the email, inform you. There's even an option to send SMS, or it can change the firewall rules. Let's say in the network you have potentially clients with a video traffic, so you want to block any kind of YouTube access until you are on a single connection, and then restore it later when you have the both connections in place. So having these scripts is something that is very unique from the Mikrotik point. Usually you don't see them with other vendors unless they are quite high-end expensive routers. With the Mikrotik in scripting language, you can execute command as you were doing configuration. So adding firewall rules, blocking certain traffic can all be captured in a script that can execute on a WAN connection down, connection up. Another interesting extension is now using additional built-in tools. There is a small application such as fetch tool or fetch command, and that actually, if you look at and you search a bit more, it can give you ability to contact external resource. So give you an idea that you could, in the case of the outage, contact a cloud service or your data center or a different site. And that script can maybe redirect your DNS, change your maybe routing, let's say even a voice service. If you have an ability to route your calls to your cell phone instead of keeping it in the office. So there's a many different possibilities, and it's all around how the service provider would like to leverage that functionality and really create a unique solution that gives more value to their customers. When we look at the cost, challenge is the two connections. The problem with having a dual connection is that very often it's actually not really needed. You have a retail store is a good example. They need redundancy, but for them to have a second link, very often end up being overkill. They don't use it. So when we look into how we can then cut a cost of having the redundant link, we're looking into 3G and LTE as the option. And there is the ability to connect using external modem, or we introduce the model which built in 3G and LTE into the router. And what this means is that you can either keep it on all the time connected and act as a second link, but really prioritize all the traffic to the main primary connection and then seamlessly fail over to your 3G network. Now, that connection, if it stays alive, it will still have some of the usage. There is a ping, there is a monitoring of that link, and it will create a bit of usage. But if you are, if it's not critical to stay kind of 100% up, then you can actually go on demand. So when there's a first link or primary link down, script can actually execute and turn the 3G service up and running, and then connect to service provider and then fail over. So yes, you have a bit of downtime, but you can save quite a bit on data usage. Nowadays, when it comes to the sites with the multiple locations, most of the service providers, Bell, Telus, Rogers, they provide a bundled a data plan, so you can have a multiple SIMs that are sharing data plan, and that actually becomes really then cost-effective to have redundancy across multiple locations. It's a pretty much one-time fee to get that hardware in place, but after that monthly cost is way lower than having in all these sites permanent WAN connection, second WAN connection up and running all the time. So we can, when you look at the 3G and LTE, the router OS has already built-in support. When it's recognized, when a SIM card, if it's compatible, it gets recognized by the router OS, that end up creating interface. There is even a further integration with the LTE by leveraging the module, LTE module and section in the router OS. And that gives a bit more flexibility in terms of how you want to configure that interface. But pretty much then it looks like a WAN that gets the IP dynamically assigned by ISP, and then you can handle the routing like you would do with any normal WAN connection. So that's, when it comes to the internet, what we came up as an alternative option for the redundancy. The power, which is the next option, first answer for power redundancy is the UPS. And that's what we see typically when it comes to the sites having a standalone or a rack mount a UPS in the network. And pretty much that UPS can, most of them be managed, which means they have some kind of a port that can be connected to device for monitoring and management. So router OS supports UPS. There is a special package. Typically, you don't see it as a bundle of the default bundle when it comes to the firmware. You have to download all packages, zip file, and then you can extract the UPS module. And once you take this module, you can just drag and drop it to your Winbox, which is most likely what you will end up using to connect to the router. And that is how you install the UPS package. That UPS will then be able to talk to UPS device using serial or USB connection. And in the case if there is an outage, UPS will provide information to the router, and router will be aware that there is the outage. It can execute certain scripts, and then when the battery is low, it can end up gracefully shut it down. Now, the challenge and disadvantage with this approach is that first, you have one UPS device where you end up connecting maybe even devices that are not necessarily need to be powered by a battery, but very often we see customers setting up devices who are just there to provide the surge protection. So when there is outage, clearly the amount of time that the network will stay up is reduced because you have more devices connected. And if the network, for example, has a server with maybe database or some kind of applications, well, most of the operative systems are able to talk also to UPS. But when this port is used to communicate with the router, that server has no idea that there was a battery, the system is on battery, and can create a data loss in the network. So unfortunately, unless you put a second UPS, there is a problem for local network. And if you want more power and more time, then clearly that's a higher cost. You have to go with the different models. When we look into that challenge, we came up with a really unique solution that is available only for the Mikrotik router, and up to date we did not notice any other vendor that actually did what we did, which is creating a micro UPS built-in into the router. In this case, what we end up doing, we actually put a battery in the device, and it can power from 30 minutes to even 6 hours. Some of the routers that have no use, this battery can provide power to the router for quite some time. Obviously, more application and more use you put. If you turn on the wireless, you put a radio. If you put a USB modem, 3G, these are all the things that will affect the drainage and it will create a shorter period of time. But when it comes to the communication, we did the same thing as the typical UPSs. We end up talking to integrated UPS over the same module that we discussed. So it's APC compatible. It's using the same protocol. And it can inform a board when it's on the battery power. And you can customize how long you want to keep it running and what to do maybe 5 minutes before on a 5% battery left, what to do with the application. To go further, when we look into design and said, okay, we can keep now a router up and running, what about DSL or cable? We have a modem that unfortunately outage of the network will cause, power outage will cause the outage on the WAN side. So we designed auxiliary out port, power port that actually will be able to have from 12 to 18 volts power out, and that will allow a modem to be powered as well together with the router for a certain period of time. So if you end up having a router with a DSL and there is a Wi-Fi built in, and you have let's say clients such as laptop, pretty much you are up and running. Your wire connections are maybe affected unless you actually have another UPS dedicated for the other devices in place. In that case, if it's a dedicated, then you can use that management for the other external UPS and talk to the server for the graceful shutdown. But there are some cases where you don't need a server and you don't need a high-end applications, and you can just maintain with a one built-in UPS. So that's actually our approach when it comes to the power outage. The next one is the router. And as we know, router being a single point of failure, there was a really interesting options what we can take from the redundancy of the power. And from the industry search, you can find there is different options, and one of them is what is called cold standby. What it means is that you end up having a replacement unit on the site. Ideally, it should be the same model and same type of the device, and it requires some manual intervention. So in the case if there's outage, the wires and connections have to be moved to another router. This is not, again, what we call 100% uptime, but it is alternative way. And interesting command from the router OS is the export utility. So you do have a backup, which pretty much can backup configuration, and you can restore it for that particular device. But if you use something called export, you can actually export all configuration. And when you export, and if you use the attribute, what's the name? Not the consolidated, but compact, thank you. When you use the compact export, that actually exports only unique configuration settings for that particular device. That configuration file, first of all, export can be scheduled, and you can do every day, every night, every week, every hour. And once it's exported, there is a FTP tool and some other option that you can actually upload that file to, for example, data center or somewhere in the cloud. But also, if you have a backup router connected locally, you could upload that configuration file to the local router. So in the case if you need to restore and configuration change, you do have a local backup that you can upload, and that's the kind of a easy way to at least keep the configuration up and running and have redundancy. Now, the good news is that router OS commands are same across all the devices. So as you probably all got a gift, you have a small 5-port unit that maybe has a very weak wireless, not a lot of CPU, but in theory, that router could actually load export for something that is maybe stronger router. Obviously, as long as the type of the hardware components are the same. So if you're missing a wireless in the other unit, you won't be able to restore the wireless. But again, from the really low cost alternative, having at least a small unit that can load and be up and running until the replacement unit is delivered, it's better than having no unit at all. So that's kind of a cold standby option. But when we look into really 100% sort of enterprise-grade routing, that's where we're looking into having additional device in place. What you see here is actually two components added to the network diagram. One is the router, and this is the router board 1100AH model. And what this is unique is that this router has a bypass port built in. Now, unfortunately, a lot of service providers are not aware of how bypass port works and what is really used for. And there's not a lot of models that we see from other vendors as well having a built-in bypass. But based on the diagram where you see, there is only one WAN connection. If you look at the earlier presentation, there were typical diagrams for redundancy are having two WAN connections to the two different routers, which means that it's extra cost. So if you have, for example, a fiber, you can ask for a second port or having a network switch somewhere in place that actually can split the connection and then have a two WAN connection in place. But then if you have really a second port of the existing service provider, that doesn't really give you then redundancy on the network side. So the other alternative is having one ISP connected on one router, the other ISP connected to the other router. But then again, we have a problem of really utilizing both connections at the same time. So what their bypass comes in, that you can actually take one WAN connection coming from either fiber, but also can be done with a cable and DSL, and you can actually pass through that connection to the second router. In the case of the network outage or power outage or the board just dies, what's happening with these bypass ports? They're actually getting cross-connected. It's a physical cross-connect. So end up being just a pass-through, and then your router down can actually don't even recognize that the network is down. It just see it as up and running. So what's happening with the configuration? To make them really seamlessly working, we're looking into VRP. VRP is Virtual Router Redundancy Protocol. And what this will take care of transferring of the IP addresses from one primary router to the backup router and vice versa. So when you look at the situation where here we have two routers and two WAN connections, actually one WAN connection passed through, we also have a LAN side. And that's where the second piece of equipment came in, which is the network switch. And it's used to actually have that connectivity between the two routers in place so they can talk to each other using VRP protocol. And when you look at the local network, now I'm talking about simplified design. I'm not talking about a BGP or SPF or higher advanced protocols to take care of the routing, which is the way you can do it. If you look at just a basic rep, you can actually end up using VRP for your LAN as well as the WAN side. So your local network is talking to the gateway, and that IP address, which is the main gateway for your local network, ends up being a virtual IP address that ends up being transferred from one router to another. I know this will be a busy screen, but I wanted to kind of capture at least the high-level configuration. And what you see is the two different routers. And when you look at the network, on the top we have a WAN network, and the WAN IP address is 10.22.22.254, so it's not a public, it's a really private, but it's a WAN connection where it's coming from ISP. But then each interface has its own IP address. And that IP address is assigned to the Ethernet ports, where virtual IP address is assigned to the VRRP interface. And VRRP interface is actually a virtual interface that can be added either to the Ethernet physical port, or it can be actually assigned to the bridge. So in this case, if it's a LAN, for example, you can assign VRP on a bridge. And in the bridge, you can actually bridge a Wi-Fi and, let's say, a one Ethernet port. There was earlier somebody asked a question about, can we use the master and slave with the VRP? Well, you can, because you can still leverage port 1 being master, port 2, 3, 4 being, for example, the slaves. So you take advantage of the switch chip and a fast layer 2 routing, but then you take that master port and you put it in the bridge together with the wireless, and that becomes your LAN. And then on LAN, you actually create virtual VRP interface where you assign 10.22.22.5, sorry, the private IP address 192.168.88.254. So in this case, we have left side, which is currently idle router. So the LAN gateway and WAN public IP, these are currently red because this is not active router. The one on the right is actually the one that serves the network. And in case if there is a network outage, at the same time, VRP is taking care of moving both WAN and LAN IP address. Well, so what this means is that if you, let's say, have a service such as VPN or a remote desktop, or you have a mail server and you have a DNS settings for your internal network, your WAN IP will also move. In some cases, the router will not even disconnect sessions. So it's so fast and it's very reliable. And it's been, I think, from version 3 already introduced in the router OS. So I know that, again, other presentation went more into details on the VRP setup. There are different ways, and in some cases, sort of different ways to cross-connect, but I'll just show you one alternative way than the other presentation. And then the last piece is the network. When it comes to the network, the challenge with the wire connection is that if you have a single network switch and it goes down, your wired clients lost the connection. Your wireless will actually be able to pick up a second access point. So in the case if you have a second access point with the same SSID, wireless clients will automatically move over connection to the a backup link, where the wire connections unfortunately will be down. And if you look at a kind of low-cost alternative, is actually taking and using some of the built-in ports and designating on the router and designating that as a LAN ports. So in this case, if the server has a mission-critical implication, you can, unfortunately, in that case, physically need to move the cable to the LAN ports, but that can be sort of a part of your disaster recovery plan. And the advantage with the Mikrotik hardware is that you can take any number of ports and combine them into sort of LAN switch. Now, you can take a bridging, what we call the bridge interface, and combine different ports. In that case, it's using processing power to actually bridge the ports around. But if you leverage the built-in switch chip, then it's not using processing power and it has way more performance for internal LAN. And the good news is that, again, it's a mix of the ports. So it's not like other routers. You have a WAN 1, WAN 2, and then you have 4 yellow LAN ports. So in this case, you can come up and, with your own scenario, how many you want to assign for the WAN connection, how many on the LAN. And you can even take and split and say, I want this LAN for voice will have only 3 ports, and this LAN will have another 5 ports with a different subnet. So flexibility in terms of configuration is quite high. But when it comes to the other network devices, then obviously they will not be connected until the replacement switch arrives. But to really have 100% uptime, we will end up needing a second switch in place. So second switch is not just any switch. What is the really recommended way, which is now more into the enterprise type of deployments, it's actually using the higher end switches with the uplink or stacking capabilities. There is almost every vendor has these kind of higher grade switches. And what they do when you stack them together, and they end up creating as a one single switch. And then that switch can be configured that you can pick port 1 on the first switch and port 1 on the second switch and group them together. And the protocol, it's called the LACP or link aggregation protocol, allows you to kind of combine the 2 ports and bond them together on the switch. And then when you look at the routers, then each router is connected to each switch. So you have this kind of cross diagram, and in the case if one switch goes down, the LCP will take care of all the routing and being able to seamlessly transfer the traffic from one link to another. Now, link aggregation protocol can also use to increase the bandwidth towards, but in this case, it's actually used to provide a seamless failover. And when it comes to the clients obviously will, in that case, need 2 Ethernet ports. And pretty much all operative systems already support bonding, and most of them LCP protocol. So you can actually have 2 links again, one going to one switch, the other one is going to the second switch. And if you need to bring additional subnets and network, then you would use VLANs. So you can still use the VLANs to propagate all the traffic all the way to the routers. But when it comes to the wired devices that are just with a single Ethernet ports, unfortunately, they have to be manually moved from one switch to another, unless they have a built-in wireless, such as maybe IP phones. When it comes to the router side, it's called bonded interface. You can actually create interface and combine multiple Ethernet ports on it. And then once you do this, there is different modes of LCP configuration that you can do. So pretty much it ends up being quite compatible. We did some deployments with the Cisco and with the Dell switches. So pretty much they are pretty much standard now. And I'm sure that if you have a higher end switches, you'll figure out a way how to use that. But that's really now getting into more larger deployments. Clearly, second switch is the higher cost, but it is the way to provide redundancy. So this is kind of a top design. You have 2 routers and 2 network switches for the redundancy.
What about double NAT?
So when you have 2 IP addresses for each router, they are different IP addresses, but they're not the one who are using for netting. What you are using for netting, what actually is the source IP address when you do the net rule, is actually VRP address. So it's a virtual IP address that ends up being moved from one router to another.
Yeah, but there's a physical device that you're doing the netting, right? But the question, you're data chaining the router, which means that you need to route packets.
Well, Well, in your configuration for the net, your source netting configuration will use the IP address of the VRP interface as the public IP address that we'll use for netting. And they're the same configuration of both routers. In these scenarios, you have only one router doing the routing at a time. The other one is idle. If the first one fails, the other one is enabled, and in that moment, that is the one who will actually end up being handling the netting.
So in the server, from the modem, you're going to one router, and then data change to another router, and then switch.
Well, if you look at the WAN side, it's kind of a green line, and the fact that there's actually daisy chain is actually taking advantage of the bypass port, so that you don't need to have a two WAN connections. So it reduces the cost of something that is a recurring cost of having a two WAN connections. You can still have a 3G as a failover. So in the case if the primary link goes down, you can still have a 3G as alternative link. But idea was to provide redundancy without really high recurring cost. And how you achieve that. If you go with the two fibers and typical design that as presented in one early presentation, that's okay as well. It just was looking into, again, showing another scenario of how this can be done. So if you are confused by that pass-through, think about it that it's actually just as a two cables. It's passing to one connection. That router is using that port as a WAN port, but in case of the outage, it's actually passing that connection to the next router, which actually is becoming the primary router, and that's where the NATIC end up doing. It's a physical connection. It's actually relays built in. So in the case, if you power out, you can see cluck and actually end up being, physically cross-connecting the ports. So end up being just a kind of pass-through, right? That's right. That's right. When it comes to resources, I mean, there is a wiki at Mikrotik.com, and I wanted to kind of bring this page because you can learn a lot. I mean, the ideas of how to achieve certain things and commands, you have to be creative, and there's a lot of examples and resources available online. There's also a lot about scripting language. So I mentioned combination of some hardware capabilities and the scripting capabilities. And there is a scripts already pre-built, so you can actually download a script for traffic prioritization, failover between the WAN connections. And you can try them out. It's very easy to kind of apply and test the script in your local lab now when you have a small devices to test it out. They're all capable to run these scripts. What is really great from the service provider perspective is that, yes, there is a customization. There is a need to kind of configure ideally your port based on your services and your clients. But that configuration can be packaged and very easily deployed and provisioned when you have a new customer. So it's not that you have to go through all this every time. Idea was to kind of create a configuration profiles and then apply them as needed for your clients. So it's easily to make it still fast, but again, unique and very different than most of the solutions from other vendors. So thank you. That's what I had for today. Is there any questions? Well, definitely. I mean, I will be in front, but I can still take a few questions. So. Mm-hmm. Yes. Exactly, and we see more and more now IP phones with the two ports, and it's funny. Very often, it's not actually the device that is a problem. Very often, the wiring is the challenge. The sites are not just wired with, usually they have only one connection for the desktop. Now suddenly you need not extra one for the phone, but actually extra two to keep redundancy. So very often the wiring is the problem, but there is a more and more wireless phones from Cisco and other devices and other manufacturers that are also possible to fail over. Even lower cost of IP phones, Grandstream, Yelling have the kind of wireless option. So that is an alternative way if there is no wiring in place. Yes?
You mentioned that you could add any configuration from one router to another. Does that act as just a backup, or does it load the config onto the secondary router?
No, it's actually just doing, first router is just doing the upload. So it's the command that actually just pushed that. So a router has a built-in web and FTP ports. So you probably notice if you log in the Winbox, there is the files on the Winbox side that actually is a storage available on the device, and if you're connected over the FTP, you could actually upload some of the files. So that's where you can upload. Now, in terms of the taking this configuration loading, then the router who received you will probably end up having a script if you want to load automatically, or you end up doing it on when there is outage, and then you want to go through setting up and loading rather than all the time reloading the new configuration. So there is a few ways to achieve that. Now, there is FTP, but there's also HTTP as well upload. So for some cloud services, when you look at for the backup, we're looking at the FTP over the HTTP or HTTPS. So it gives you then more secured transfer rather than FTP if you're going through public internet. So that's another option. Yes? So if I understood your question, you're saying if the VRP capability will be available from the... Well, currently, Mikrotik by itself has no cloud-based management. Macrotick, we are actually putting in place the cloud management services. We did a kind of first version, which is more a portal, more to gather information. We visited several MAM shows and got a great feedback, and we're about to launch the new version called cloud.macrotick.com. And it's still more on the monitoring end. I did other presentations at MAM in US. I think they're available on the Mikrotik websites where you can kind of take a look of these presentations. It's a really unique way because it's not using SNMP or APIs to connect to device, because we have challenges often to go to the router. We see more and more service provider providing private IP addresses because IPv4 is not available anymore. So very often you cannot get to the router to monitor from the cloud. So our design is different. We're actually gathering information and pushing that to the cloud using HTTPS. So it's a secured, it's a firewall friendly, and gets that informed on a cloud. So in that case, it's just the monitoring. When it comes to the management, the API is available to manage from the cloud, and that's something that maybe you want to research more, how that can be done remotely. Thank you. I will be still available outside if there is more questions. Wish you all a great day, and thank you. Who borrowed this? Oh, thank you. Power supply? Oh, is it there?